Another type of reaction we're going to look at is reduction. Here I have got a solution of potassium permanganate which has been acidified with sulfuric acid. You can see that it's a purple colour. And here I've got hydrogen peroxide, which is H2O2. What I'm going to do is I'm going to combine the two and look for any observation. And we can see that the purple colour of the permanganate has faded considerably. Now, if I looked at it carefully enough, I might have seen some bubbles forming as well, although that's pretty hard to see in there. So what we say is that the permanganate has been decolorized. This is an example of a reduction reaction. And reduction reactions are the opposite to an oxidation reaction, which we've already learnt about. They occur when oxygen is lost from something, or when something gains hydrogens. The actual definition, though, is the gain of electrons. And so you might remember from our last video that we had these two things. Leo goes Ger, loss of electrons oxidation, gain of electrons reduction, or, oil rig, which is oxidation is losing when we're talking about electrons, reduction is gaining when we talk about electrons. The other way to remember it, when we do oxidation numbers, and we can assign those, if you see the oxidation number decrease or reduce, you know you've got reduction. Hence the word, the reduction in oxidation number. Okay, so what just happened in our test tube here? Well, the purple permanganate has been reduced to the nearly colourless manganese 2 ion, or manganese 2 plus. You can see this one has oxygen atoms in it, and this one does not. So therefore that sort of fits our first criteria. The loss of oxygen is reduction. Well, we actually need to show it as a transfer of electrons. So we do that by doing a thing called a half equation. A half equation has electrons in it, so it's not actually a complete equation. Complete equations don't have electrons. So we're going to look at how to balance this one. And we already met hydrogen peroxide before in our last video showing it oxidizing. So I'm going to use that as my example to show this is quite a special chemical because hydrogen peroxide can be reduced as well. So I'm going to use those two to show you how to write a half equation. Right, so here we go. Permanganate, which is the purple stuff we started with, was turned into manganese 2 plus. Which is the nearly colourless stuff that we ended up with. The first thing I look at is the metal that's involved, the Mn. And I see there's one on this side and one on this side. So that's balanced. So we're pretty good so far. We don't have to do too much. Then I see these oxygens here. Well, these oxygens need to be balanced on this side. So I've got to think of a chemical that I can use to balance those out that won't actually affect anything. Well, these were both aqueous solutions, and aqueous solutions means things dissolved in water. So I can use water to balance this out. So I'm going to have 4 oxygens giving me 4 waters on this side. Great, my oxygens are balanced. The problem is water also contains hydrogen atoms. So that's thrown things out a bit for me. So I need to balance those out. Well, you might recall me saying that the original solution was acidified. It had sulfuric acid in it. Acidified solutions have H plus ions in them. So that means that I can actually put H plus ions on this side to balance these. 4 waters, each water with 2 hydrogens means 8 hydrogen atoms. So I need 8 hydrogen ions. So now all of my atoms are balanced, but my charge is not. On this side, I've got a -1 here, and I've got a +8 here. So this side has got a +7 charge at the moment. And over here, I've got a +2 for that, and no charge for water. So I've got a +2 charge over here. I need to get them both down to the lowest number. So I need to get them both down to +2, because I can only balance out charges with electrons. Electrons are transferred, nothing else. So I need to get this one to be 5 lower. So I'm going to put 5 electrons in there, and electrons have a negative charge. So now this side is -1 plus 8 is plus 7, minus 5 gives me plus 2. They're both the same charge. I've balanced my half equation. This is one of the hardest ones you do. The other one that's really hard is a chemical called dichromate. So I'm going to quickly go through that one now as well. And then, as I said, I'm going to show you what's clever or special about hydrogen peroxide. Okay, dichromate. Dichromate, when it's reduced, becomes chromium 3+. This stuff's orange, and this stuff's a bluey-greeny colour. You'll see it as green normally. This one's a bit harder because most people forget to notice that the chromiums are not balanced yet. There's 2 on the side and only 1 on this side. So we start by putting a 2 in front of the chromium there. Then, same as the permanganate one, 7 oxygens means 7 waters. 7 waters means we've got 14 hydrogens. And then I do my maths. 14 minus 2, because this is a negative charge, is going to be plus 12. Now, this is a common mistake. 2 times plus 3 is plus 6. So to get it down from plus 12 to plus 6, I need 6 electrons. And so there we are. This one is now balanced. And then my last one I'm going to look at is hydrogen peroxide. Now we know that this can be oxidized to become water. It can, to become oxygen. It can also be reduced to become water. Now, this one looks really hard to balance, but it's not. That extra oxygen has to become a water. Okay, so H2O plus H2O gets written as 2H2O. 2 H2s, there is 4 hydrogen atoms. There's only 2 over here. So I need 2 H pluses. This side has no charge. This side now has a plus 2. So 2 electrons. What you'll notice, I hope, is that electrons are always on the left-hand side, on the reagent side. And this is showing us our gain of electrons, because they're having to be added before these things can react and become those other things. Where do those electrons come from? They come from the thing being oxidized. So in our original video, we had magnesium being burnt. The magnesium was losing 2 electrons and giving it to the oxygen atoms in the molecules in air. The oxygen molecules in air were becoming oxide, O2 negative. So in reduction, you're looking for the electrons to be on the left-hand side of the arrow, which shows that they are being gained by these things so that they can be reduced. Makes sense, really. Negative charges reducing their charge, which is effectively what a reduction in oxidation number means.